Hello friends, welcome to my YouTube channel Hydrogen Masterclass. So hydrogen is talk of the town, especially green hydrogen. Many countries have developed their hydrogen policy and soon India will also have its one. From Ambani to Adani to Toyota, all are betting big on the hydrogen. I thought of creating series of hydrogen masterclass covering all aspects of hydrogen. I am planning to cover hydrogen generation techniques, economics of hydrogen generation, in detailed discussion on electrolyzers, fuel cells, hydrogen storage, hydrogen transportation, and various use cases of hydrogen. Also capturing key news during at the end of every week. However, it's important to understand the origin of this much talk about element, that is history of hydrogen in brief, and properties of hydrogen to understand its generation, storage, and transportation in detail. So let's start with the uh, brief on hydrogen. If you have not liked this video, then please hit like button and subscribe my channel for notification on new videos. 13.7 billion year ago, big explosion happened, a big bang, and that is the starting point of universe and our hydrogen too. First element created after the Big Bang was hydrogen. Hoimer von Ditfurth, a German physicist and scientist journalist, stated that in the beginning there was hydrogen. Jules Verne, a famous French novelist, also has written his novel The Mysterious Island that water will be the coal of the future. He was much ahead of his time, of course. He further said in his novel, I believe that water will one day be employed as fuel, that hydrogen and oxygen, which constitute it, used singly or together, will furnish inexhaustible source of heat and light of intensity which coal is not capable of. Robert Boyle produced hydrogen gas in 1947 while he was experimenting with iron and acid, but it was until 1766 that Henry Cavendish recognized it as a distinct element. The name hydrogen, that's a hydrogene, which means water producer, was first coined in 1787 by the French chemist Antoine Laurent de Lavoisier from the Greek words hyd. In Greek, hydor means water and gene means producing. So hydrogen cars are also having their traces back in 18th century. So this is the first car made in 1807 by the Swiss inventor Francois Isaac de Rivaz. It's a four-wheel vehicle which was powered by the hydrogen and oxygen. Hydrogen gas was stored in balloon. It's very primitive but very effective fuel cell. This is another hydrogen power car which was made by Etienne Lenoir, a Frenchman, in 1860. It was developed as a hippomobile, a large transporter type vehicle with hydrogen based combustion engine. It successfully went from Paris to Joinville-le-Pont in 1863 during test drive. Now let's go through properties of hydrogen. In periodic table, hydrogen is the first element. Its atomic number is 1. The molecular formula of hydrogen is H2. Hydrogen is the lightest element. Its atomic weight is merely 1.08. And the hydrogen World Hydrogen Day has been derived from this fact 1.008, and it's on the 8th of October every year. At a standard temperature and pressure, hydrogen appears colorless, tasteless, odorless, non-metallic, non-toxic, and highly combustible diatomic gas. So we can see here in this chart, boiling point of hydrogen is minus 253 degrees centigrade. Below this temperature, hydrogen is liquid under normal pressure of 1 bar. And critical temperature of hydrogen is minus 239, rather to minus 240 degrees centigrade. At critical temperature, all three physical states, that is solid, liquid and gaseous state, exist. Melting point of hydrogen is minus 260 degrees centigrade under normal pressure. In case of hydrogen, liquefaction normally takes by cooling rather than by compression. Now, hydrogen actually exhibits negative Joule-Thomson coefficient, which means uh, while hydrogen is expanded all of a sudden, it gets heated rather than cooled. So other gases, when expanded all of a sudden, it gets cooled, whereas the hydrogen gets heated. At a temperature of 0 degree centigrade, the density of hydrogen in its gaseous state is 0.089 gram per liter, which is very less dense. And at a melting point of minus 260 degrees centigrade and 1 bar, its density is 76 gram per liter. Hydrogen is having extremely high diffusibility. Hydrogen gas is highly flammable in air. Pure hydrogen oxygen flame radiates ultraviolet light. Further, with high oxygen mix, are nearly invisible to naked eye. So that's the reason we need to wear ultraviolet glasses to see hydrogen flame. If hydrogen is burning, you cannot see it with the naked eye, and if you enter into hydrogen flame, you all of a sudden catch it. The ignition range of hydrogen, marked here in yellow, is it's very large. The lower limit is a concentration of 4% by volume, and upper limit is 77% by volume. Where if you see in other fuels, this particular range is very narrow. That means mixture of this fuel and air is only combustible in that narrow range of mixture, whereas hydrogen is having very large mixture. That means even if a small mixture or a large mixture is present in air, it is combustible. The auto ignition temperature of pure hydrogen is 585 degrees centigrade, which is higher than that of conventional fuels. However, minimum ignition energy required is very less, which is 0.02 millijoule. Now, of all baryonic masses, 75% is hydrogen, and hydrogen is most abundantly found chemical substance in the universe and the richest energy source for the stars like sun. Throughout the universe, hydrogen is typically found in atomic and plasma state. However, the properties quite different from those of the molecular hydrogen. In the plasma state, the non-Raman star are primarily composed of hydrogen. On the Earth, hydrogen exists in a diatomic gas, that is in a H2, in its molecular phase only. Because of having a light weight, hydrogen easily escapes from Earth's atmosphere. Hydrogen is the third most abundant element found on the Earth's surface, but largely found in the form of hydrocarbon and water. Other major compounds of hydrogen are ammonia, hydrogen chloride, methane, hydrogen sulfide, hydrogen fluoride, hydrogen bromide, methanol. So right now hydrogen is much touted for transportation through ammonia or through methanol. So both are being talked about for as a carrier of hydrogen. Now 1 kg of hydrogen contains 0.142 gigajoule of energy, which is very high. It's equivalent to 39.4 kilowatt hour of perfect conversion to electric energy, which is 39 units, we can say, or 0.13 MMBTU, and both are values at a high heating value. So let's compare now hydrogen with other fuels, other conventional fuels. So if we compare with the coal, calorific value of coal is between 10 to 25 depending upon the type of coal, which is lower in the typical fuels, and carbon content is very high in a coal. It's up to 90%, and hydrogen percentage is low, which is 5%. uh, kg of carbon dioxide emission per megawatt hour of energy produces around 380 to 340 kg of carbon dioxides are being emitted. And volumetric density, that is a energy per liter of coal, is 26 between 26 to 49 megajoule per liter. Now let's go to diesel. In diesel, calorific value or its gravimetric density is 45 megajoule per kg. Its carbon content is 86 percentage, which is much better than, I would say, coal. Then hydrogen content is 14%, and because of this, emission is lower than coal up to certain extent. It's a 270 kg of carbon dioxide emission per megawatt hour of electricity produced. And volumetric density is also uh, better than slightly better than coal. It's a 36.9. It's a in between a range of coal. And let's go to the natural gas. In natural gas, gravimetric density is even better, which is between 42 to 55 megajoule per kg of natural gas. Carbon content is lesser than coal, and even with compared to diesel, it's a 75%. Hydrogen content is 25%, and because of this, emission is also slightly lesser than diesel and coal. So it's a 200 kg of CO2 emission per megawatt hour of electricity produced, and volumetric density is 20 megajoule per liter. Now let's come to hydrogen. Hydrogen is having one of the highest calorific value, which is in a fuel, which is 142 megajoule per kg. So it ranges between 120 to 142 megajoule per kg, which is three times of natural gas. It contains zero carbon. It contains 100% of hydrogen, of course, and because of this, there is zero carbon emission, and that's the reason why green hydrogen is so much talked about. However, its volumetric density is very less. It's a 8 megajoule per liter, and that's another reason why it's not uh, as widely adopted as renewable energy. I mean, or solar energy or wind energy. However, we'll see in our other next master class of hydrogen that how um, hydrogen is stored despite of this volumetric density, or other some of the new technologies, and how hydrogen is transported despite of this challenge in volumetric density. So goodbye till next video. We'll see you in the next video on hydrogen masterclass. Bye friends.